Hello, fourth grade. Welcome to video 3. Can you believe it? 3 videos down and you're on a roll. Today we are learning about 4.3 finding halves of crazy cakes. What are crazy cakes? You'll soon find out. Before we do that, let's review what we did yesterday. I had you write down in your notebooks the definition of area, so if you want to recall that one. Area was the size of the surface or the amount of space inside that flat shape. And let's take a look at what we did in class today. We started off by looking at our figure and finding the area of equilateral triangles that made up this figure. And we found out that there were 15 on each side for a total of 30 equilateral triangles, or 30 units. Here we have Jaden at the board, and he was demonstrating for us how he identified the equilateral triangles within the trapezoids. And we had, I believe it was Francie, who was finding hexagons and other shapes within the figure. So way to go. I was also thrilled to see you working in your small groups today with your math packets. You guys got a lot of really great work done with some deep thinking. I love that you applied your knowledge from the video and used it to solve these difficult problems on your own or even helping a student out. So way to go, keep up the good work. Get your pencils ready because we have a new definition coming in. And that word is congruence or congruent. Please write both parts and actually say that word out loud so you can hear how it sounds. Congruence or congruent. And what that means is if one shape can become another shape through a flip, a turn, or a slide. And so I have a few pictures for you to demonstrate which each of those are. First, I have a flip, which is actually going to use that line of symmetry, and the figure is actually going to be flipped over. So think of like a pancake cooking on the griddle. I can lift it up and flip it over completely. Next, we have a turn. Imagine a figure on a table and you're just going to pivot or turn that figure without lifting it up at all. And you can use any of those 360 degrees to turn it. And finally, we have the slide. So still keep that figure right on the surface of your table and you're going to slide it in any direction. If your shape can look like another shape, either by sliding, turning, or flipping, your shape is congruent. Let's take a look at that in a little bit more detail with an example. I would encourage you to cut out a piece of paper, rip a piece of paper if you want to, and practice doing this with me. I'm just going to go ahead and draw a triangle on my page, and I'll fill it in with some color. All right, first let's take a look at the flip. I'm going to add a line of symmetry on my page just by drawing a straight line down. Remember the flip I compared to a pancake, actually taking it off the griddle and flipping it over. I'm going to do the same thing through the magic of my smartboard. I have to use the word flip and I'm going to flip it over to the right. Okay. To give you an idea of what that looked like originally, let me flip it back. So here was my original triangle, and I flipped it over. So these two images are now congruent. Looks like they're two different shapes, but they're actually the same through that flip. A flip can also happen up and down. So if I scoop my triangle up, let me flip this one back. And I can flip this one down over the line. So notice how the bases are still the same. If I were to fold this one up or flip it back up, it would become the same shape. Those are congruent. Next we had the turn. So I'm going to go ahead and get rid of a couple of the shapes here on my page. And I'm going to demonstrate the turn by clicking on the green rotate handle that's here at the top. I can click and rotate my shape around. That's a turn. The shape remains the same, and any shape that I had on here, if I clone that again, and I rotate one, these shapes are still congruent. One is just turned. And finally, I have the slide. The slide, I'm going to keep the actual shape still on the paper, and I can slide it in any direction. And these shapes are still congruent. Same shape, same area, congruent. All right, let's take a look at one more review piece. Today I mentioned a vocab word that we didn't highlight and we hadn't written down in our notebooks yet, so I want you to add that today, and that is called mirror symmetry. Hopefully you remember me saying that today. And that was when we had a figure or a shape, and we could cut that shape completely in half. So far, all the symmetric images I've been showing you of the ladybugs and the butterflies and the castle and the ladder, those shapes could all be cut in half, one way or the other. And then with that half, if we applied a mirror to it, it would still look like a complete shape, or the original shape, because one side is an exact reflection of the other side. When that happens, it's called mirror symmetry. So if you would please write that down in your notebooks, mirror symmetry, and you can either draw a picture, which might be kind of hard to do, or write down it's an exact match to the other half. All right, our lesson for tomorrow is called Crazy Cakes. Not those kinds of cakes, but these kinds of cakes. Imagine this is a birthday cake. And let's say this birthday cake, this odd-shaped birthday cake, needs to be shared equally between two people. Now this is an unusual size or shape of a cake, so that's why we're calling them crazy cakes. How could you cut this cake so that each person has the same amount of cake? Now the pieces of cake don't have to look the same, but they have to have the same area. See if you can figure out where I should draw my line of symmetry in order to make these halves equal. I'm going to draw my line right down the middle. Do you see how each half is the same? Imagine if I had cut this little piece off and added it down below. See how this little nub out here will complete this half of the rectangle, giving me two complete rectangles? Well, if so, you've just completed your first crazy cake dissection. Let's try another one. Try to divide this crazy cake. Use your imagination. Do you see where I can divide it? I'm going to draw my lines just to show you a little hint. Does that help you at all? I hope so. Hopefully you see that this is still a rectangle underneath there. And by drawing my line right down the middle, each person is going to get a rectangle piece of cake as well as a side triangle. All right, tomorrow you will have shown mastery of this skill if you can flip, turn, and slide a figure, if you can define congruent and possibly mirror symmetry, and if you can split some crazy cakes into two equal pieces. Thanks. Good luck. See you tomorrow.